Today, we are here for a presentation about string sizing and proper PV design. So string sizing is a very important part of proper design and installation. And it's one of the most important ways to optimize your system. If you don't optimize your string sizing and the MPPT arrangements, you will not get the best production from your solar plant, and we know that that can cause more problems. So my name is Nick Lusson. I work with Jubilee Bro Solar based in Nairobi, Kenya, and we look after all of East Africa from Nairobi. So let's begin, and I'll start by telling you a little bit about Jubilee Bro Solar. Jubilee Bros was founded over 40 years ago in Lebanon, mostly as a diesel generator company. And as you can see the timeline there on the screen, we continue to expand into many countries, including UAE, Nigeria, where we now have around 1,000 employees, Afghanistan, Kuwait, Ghana, Qatar, Uganda, South Africa, Pakistan, Kenya. And the solar division was founded in 2017. So here is a map of our global logistics reach. Everywhere that you see a flag, we have customers or distributors or sister companies. So you can see it's quite a big reach across Africa and South Asia. And here we have 6 pillars of activities that we use to support our EPC customers. You can see them on the screen. The first one is product supply. So we can supply high quality products to you. That's simple. Number 2 is training. So we do lots of training like this one on many different topics, especially to do with diesel generators or your Huawei inverters. But we have a wide variety of topics. And if you have any topics you would like us to do training, just send us a message and we'll try to do that. Pillar number 3 is engineering support. So this is like pre-sales support. Basically, we can look at your solar designs and verify them. We can make sure nothing is duplicated, nothing is missing, and the equipment is being used properly and it is optimized. 4th pillar is leads, because from time to time we engage with the end users and they require leads or referrals. So we're happy to make those referrals to our qualified partners. The 5th one is referral to finance, because sometimes we know in the solar industry, the obstacle is the upfront cost, the CapEx. And we have partners who are happy to finance your solar projects. So we are happy to make that connection to help you get your projects across the finish line. And the 6th pillar is after sales support. This is commissioning support, warranty support, and troubleshooting support. So basically our business model is to supply and support. And now with Huawei, we have a strong partnership with Huawei. We are a tier 1 partner of Huawei, the VAP and CSP. VAP means value added partner. So we handle inquiries for Huawei inverters up to 100 megawatts. And CSP means certified service provider. And this is important because not all VAPs are CSPs. We are trained and certified to handle your Huawei service related issues. Okay, so now we can get started on the topic today. String sizing and proper PV design. As I mentioned, this is very important for the optimization of your PV plants. And the outline that we're going to follow today, we start with determining the system capacity, the requirement for the solar. We'll talk about equipment selection, we'll talk about the string design, and we'll talk about running a simulation. All right, so the first step, if you have a customer who wants solar, you have to determine their load requirement. So there's 2 ways to do this. and you should probably do both if you wanted to be very certain. The first is you can look at their electricity bills, and that will give you a good idea of how much electricity they are consuming. And especially if they don't operate at night, this can give you a good idea of their solar requirement. But the better way is to get a 24-hour load profile. To do this, you will want to install a load analyzer at their site and leave it there for about 7 days so that you can get 7 days of data, 24 hours a day for 7 days. This is important because you can get the result of something like this graph you see on the screen, where the blue line is their load and the red line is the solar capacity available during the day. We know that the peak hours of the sunlight happen in the noontime. And then, of course, the early morning and evening, there's not much sun. So it's important that you get this 24-hour load profile so you can calculate accurately how much potential of their load can be carried by the solar energy. And this also gives you a chance to do some optimization on their load, because you can ask them to try to move the evening loads to the peak hours of the sunlight, and that would maximize their solar load. So once you have done that, you have to take into consideration the space requirements or the space constraints. If this is a rooftop solar, you will be limited by the space of the roof. And in some cases, not all of the roof space is utilizable. So you have to do these measurements and calculations and be aware of the space constraints. And if it will be ground mount, generally there's more space, but you may have some issues with shading and trees and tall buildings. So all of this you have to take into consideration with the space requirements, the space constraints. Okay, next is the DC to AC ratio. So the ratio of the DC capacity to the inverter's AC rating is the DC to AC ratio. So you calculate the DC is the wattage of the solar panels, and you add them all up. That's your DC capacity of the solar. And the AC is just the rated capacity of the inverter. So ideally speaking, the DC to AC ratio should be between 1.2 and 1.4. So we use 1.3 as the reference. 1.3 is a good number. If it's between 1.2 and 1.4, you're doing pretty good. So we use 1.3. The reason for this is there's system losses, there's DC losses, so not all of the DC capacity will reach the inverter. However, also, this is for extra production in the early mornings and the afternoons. So during the peak hours of sunlight, there may be some clipping with the 1.3 DC to AC ratio, because the DC will be more than the AC can handle. But that clipping will be minimal because the peak hours of sunlight does not happen very often and it does not happen very long. So when you have a DC to AC ratio that is above 1, so if it's 1.3, that means all of the off-peak hours will give you additional production. So the mornings before peak sunlight and the afternoons after peak sunlight, you will get more production. So your load profile, we call it the shoulders. Your solar production will be expanded sideways. If you go above 1.4, it's usually not economically feasible anymore. It doesn't give you a good return on your investment above 1.4. So 1.3 is a good DC to AC ratio. So we have an example on the screen. So let's look at the inverter. It is 10 kilowatts, 10 kilowatt inverter. So we want a DC to AC ratio of 1.3. So that means we want to come close to 13 kilowatts because 10 kilowatts of AC times 1.3 equals 13 kilowatts. So the example on the screen, we're using 450-watt panels, 28 pieces. That gives us 12.6 kilowatts. Then at the bottom, you see the calculation. The DC to AC ratio is 1.26. That's fine. That's a good ratio. So that scenario is a good example of DC to AC ratio. Now here we have another example. We're using a 100 kilowatt inverter. So 100 kilowatts times 1.3 equals 130 kilowatts. So we want our DC capacity to be around 130 kilowatts. So in the example, we're using the 450-watt panel, 18 pieces per string, 16 strings. And when you do that math, it comes to 129.6 kilowatts. And when you do the DC to AC ratio is 129.6 divided by 100, you get 1.296. So that is very close to 1.3. That is a good DC to AC ratio. All right, so now we're going to talk about equipment selection. And there's two parts of this. There's the DC components and the AC components. So in the DC components, it's the panels and also the mounting structure, even though that's not electrical, but it's related to the panels. And on the AC components, we have the inverter and the accessories. All right, and we're talking about Huawei today. So with the Huawei solution, you need three components. They're there on the screen. You need an inverter, you need a communication device, and you need a power meter. So that's all you need, only that. And we're going to go into more detail on the next slides. So let's start with DC. Let's start with the panels. So on the panels, there's many different things that you should consider. And I've put them there at the bottom with the white bullet points. So you need to consider the maximum power. So that's P max, that's the wattage of the panels. But also the maximum power voltage, which is VMP. The maximum power current, IMP. The open circuit voltage, the short circuit current, the maximum series fuse rating. That's important if you're going to use a Y branch connector. Also the temperature coefficients, because the location on Earth of your solar plant will affect the production, because the temperature of the panels affects their production. So that's something to be aware of. Also the panel efficiency. The tier 1 panels are usually very good, but if you're using cheaper panels or polycrystalline, the efficiency goes down. Also, as I said, the cell type, mono or poly, monocrystalline or polycrystalline. And also the warranty. So these are all important things to consider when you're selecting your panel. And all of this can be found on the data sheets of the panel. So here is an example of the Jinko Tiger Pro. On the left, you see the full data sheet, and on the right, I've just highlighted the actual data there. And that's what it looks like. So you should get very comfortable looking at data sheets of panels to find this information. Generally, they present it to you very clearly. So you'll be able to find this. It's in a table looking like something like this. Almost all manufacturers will have an easy to read data sheet with that table. Okay, and you should also consider the mounting structure, and that's important for what type of roof you're using, and also the thickness of the panel and the size of the panel, if they're very big or small, for example. So generally, aluminum is the material of choice because it is lightweight and it does not rust. So using a good aluminum mounting structure is recommended, and they can generally be used on any application. steel roof, concrete roof, as long as the roof is strong enough, and ground mount, and so on. So this will vary from installation to installation. Okay, next, inverter selection. So the most important part of the inverter selection is your AC requirement. All right, so that's whether you require 50 kilowatts AC output or 250. Now, the Huawei inverters are string inverters, so they're made to connect with each other. So most sites would have multiple inverters, and they communicate with each other and they work together seamlessly. This is called string inverters. So on the screen is the Huawei C&I range of inverters, commercial and industrial. So there's usually, you can combine them in any way you want. So let's say if you have 120 kilowatts requirement, you could do one piece 100 and one piece 20, or three pieces 40, or two pieces 60. So there is a lot of flexibility there, and you can make those decisions. And what you need to pay attention to is there on the screen there, the white bullet points on the bottom. The AC capacity, you want to pay attention to the output voltage. If it's medium voltage, like 415 volts AC, or high voltage, you may need 800 volts, you may need a transformer station. So pay attention to the output voltage of the inverter to make sure it matches your voltage at the grid connection point. So all of these on the screen have 400 or 415 volts AC. Also the input voltage. Some Huawei inverters allow 1,500 volts DC. These ones on the screen, they all allow 1,000 volts DC. Also the input current. This is very important. We'll talk about this on the next few slides. But the input current. Also the warranty is important. And also the IP rating, whether it's waterproof, IP66 or IP65. So these are important things to consider when you're comparing inverters and making your choice. So all of these features in Huawei are basically industry leading. So Huawei, in another presentation, we talk about all the benefits of Huawei inverters. But generally, Huawei is leading the industry on all of these. So again, this is the data sheet for the inverter. You should get very comfortable looking at the data sheet of the inverter. Again, I've shown you on the left what it could look like, and on the right, I've highlighted some of the data. So it's in a table, it's very similar to the panels. You can find all of this information on the data sheet of your inverter for almost any manufacturer. But now you need to make sure the panel that you are selecting and the inverter you are selecting are compatible. So here on the screen, I have put on the left side is the data for the 100 KTL inverter, and on the right side is the data for the Jinko Tiger Pro 550 watt inverter. And I put those arrows there because I want to highlight a few things. I know it may be difficult to see, but I'll explain it. So first, if you look at the orange arrow on the left and on the right, on the left, on the inverter, that is highlighting the nominal input voltage. Nominal input voltage. That means it is the voltage at which it will perform the best. So nominal voltage or rated voltage will tell you the optimum efficiency of that inverter at that voltage. So you can see there it says 720 volts at 480 volts AC. Okay. So again, what that's telling you is that the input voltage of the DC should be close to this number for the best production and performance. And on the right side, again, the orange arrow, it's the maximum power voltage. So you should pay attention to that maximum power voltage because that means at the peak sunlight, that's the voltage your panel will generate. Now also look at the yellow on the left. That's the maximum input voltage. It says 1,100 volts. And then the green arrow is the MPPT operating voltage range, 200 volts to 1,000 volts. So that means if your panel is generating a voltage between 200 and 100, the inverter can operate. If you exceed 100, it will not operate and you will get a warning. And the max input voltage is 1100 volts. If you exceed 1100 volts, you will damage the inverter. So the operating range tells you the range it will operate. And if you exceed 1000 volts, you will get a warning. But if you exceed 1100 volts, it will damage the inverter because that's the maximum input voltage. You should not exceed the maximum input voltage. And then the blue arrow on the left is the max current per MPPT. It's 26 amperes. And on the right, the blue arrow is the maximum power current. So that means this is the current that your panels will generate at peak sunlight. So if you can see closely there, it's 13 amperes on the panels. That is the maximum power current. And on the left side, max current per MPPT is 26 amperes. Now, a very important part about Huawei inverters is that they allow 2 strings per MPPT. Each MPPT can accept 2 strings. So that means the max current per MPPT is 26. So each string should not exceed 13 amperes. So that's very good here. This matches well because the amperage I've highlighted is on the panel is 13.07. 13.07 times 2 is 26.14. That's more than 26. If you exceed the max current per MPPT, it will not damage the inverter. You will just see current clipping. It will not operate very efficiently or maximum efficiently. But this is fine. It's very, very close. And the peak hours of sunlight do not happen often and they do not happen for long times. So this is fine. Now, sometimes there are even larger panels, like 650 watts, and their max power current will be more than this, maybe 15 amperes. So if you're using a big panel that has a high max power current, you have to check the inverter and see if it can handle that. The very large panels are not made for these small inverters. We've seen this problem recently. If you're doing a small installation like 5 kilowatts, generally you should not use the very, very, very large panels because the inverter will not match those panels. A 5 kilowatt inverter is not made to handle a 650 watt panel. So that's why this step is very important. You need to check these parameters with the panel and the inverter to make sure they're compatible. Now, the Huawei CNI range of inverters is made to accept these large panels. The residential inverters are not. So those CNI inverters are fine for these large panels. The residential inverters are not. But one thing to pay attention to, if you're using a very large panel, and let's say the max power current is 15 amperes, and you look at this inverter and the max current per MPPT is 26 amperes. So remember, this is max current per MPPT. Each MPPT accepts 2 strings. So you probably should not connect 2 strings to the same MPPT if the max power current is 15, because then it would require 30 amperes in that MPPT. So that's fine. you would just connect one string to that MPPT. You will not connect two strings. So I'll make that a little bit more clear in a few slides. Okay, so after you've identified your inverter, you have to identify your communication device, because this is what allows you to monitor remotely. So on the screen, see, I have the big OR in the middle, because you can either use a smart dongle on the left or a smart logger on the right. You do not need both. You choose one. So at the bottom in the gray area with the white text, I've tried to make it clear. So let's look at the smart dongles on the left first. There's two models. There's the 4G model and the Wi-Fi model. The 4G model requires a SIM card and you have to keep uploading data. So I personally prefer the Wi-Fi model and I recommend to use it whenever possible. If you can see there, it's compatible, all the inverters 40 KTL and below. 40 KTL and below are compatible. Also, the smart dongle can manage up to 10 inverters. It cannot manage more than 10. If you have 10 inverters, you can use a single smart dongle. It's not one per inverter. You can manage up to 10 inverters with the dongle. Now, the smart logger works with all of the sizes above 40. It works with all of them as well, but the 50 and the 60 and the 100, you will use a smart logger. Also, the smart logger can manage up to 80 inverters, 80. So it's for bigger installations. So there at the bottom in the gray, I've tried to make it clear on the left, you can use the Wi-Fi smart dongle if you have less than 11 inverters and at least one inverter is 40 KTL or below. Because you only need one inverter to be compatible with the dongle. So you could have 5 pieces 100 KTL and one piece 20 KTL, and you can use the dongle to manage all of them. As long as one of your inverters is compatible with the dongle, and as long as there's 10 or less, you can use the dongle. Otherwise, you use the smart logger if you have more than 10 inverters. If you have none that are 40 KTL and below, none that are compatible. And if you have a weather station, you will need the smart logger. So we have another webinar that goes into a little bit more detail. Today, we're just helping you do the design, choose the equipment, and we'll get to the string sizing. So if you need more information on these, there are other webinars for that. And the last piece of the puzzle is the power meter. So this is for export limitation. If you're not allowed to feed into the grid, or if you want to limit the feeding into the grid. So on the left, we have the Huawei solution. It's called the Smart Power Sensor. And on the right, we have third-party meters that are compatible. So the Smart Power Sensor, if you look at the gray on the bottom, it has a size limitation. Basically, the AC requirement, the total AC requirement should be less than 170 kilowatts. Also, the grid incomer cables should be smaller than 24 millimeters. That's because of the size of the CTs. Now, if you have a larger project, if it is larger than 170 kilowatts AC, if the grid incomer cables are larger than 24 millimeters, you will need to use a third-party power meter. And there's a small list on the screen, and we have more webinars for this in more detail. So the point of this is you have to choose your inverter, you choose your communication device, and you choose your power meter. Okay, now we're going to talk about string design. Once you have your equipment selected, we can start designing the layout of the system. So we are going to answer these questions on the screen. How many panels should you use? How many strings should you use? And how many panels per string? And then the string and the MPPT arrangement. That's what we're going to talk about now. Okay, so here is the formula to calculate the modules per string. This is from the IEC, the international standards for this. So as you can see, it's a slightly complicated formula. You have to take into account all of these variables here, the VDC max, the VOC, the temperature, the open circuit voltage temperature coefficient, the V startup of the inverter, the maximum and the minimum temperature of the PV modules at the annual historically highest ambient temperature. So it's a complicated formula. Fortunately, we have done something to help you. We have a string sizing tool. Jubilee Bros has a string sizing tool. And all of you will receive it in your email after this webinar. You will all receive this. It's an Excel sheet. So step one, there's a screenshot there. Step one, you select your inverter. It's only Huawei inverters on this. You select your inverter from the drop-down list. Number two, you input your annual high temperature and annual low temperature at the location. So you can find this on Google or something like that. Find the annual highest temperature at that location, the annual lowest temperature at that location. Step number three, you have to input your panel values. So this will come from the panel data sheet. So there's the VMP, the VOC, and so on. So you should input that data. And step four will give you the results. It will tell you the minimum number of panels in a string. It will tell you the maximum number of panels in the string, and it will tell you the optimum number of panels per string. So this makes your life very much easier, and you will receive this Excel sheet in your email after this webinar. Let's go through some examples. So example number one, we have a 60 kilowatt AC requirement. So if you look in the center of the screen, we have it broken down, step 1, 2, 3, 4, 5. So step 1, once you know the requirement, you know the 60 kilowatt AC requirement. So step 1 is to calculate the DC to AC ratio. 60 kilowatts AC times 1.3 is 78 kilowatts DC. So we want approximately 78 kilowatts DC. Step 2 is check the space requirement. So we will just assume the space is okay, there's enough space. Step number 3 is you select the inverter. So you know that you need 60 kilowatts AC. So Huawei has a 60 kilowatt inverter. So there you go, 60 kilowatt inverter. That's the one we're selecting. Step number 4 is you select the panel and you confirm the compatibility. So we have selected the Jinko 450 watt panel, and we have to check the compatibility like I showed you. We compare the data sheets. We look at the max current per MPPT and the voltage, and we have checked it, and it works, and it's okay. So now step 5 is you calculate the total number of panels. So remember, our DC requirement is 78 kilowatts. So we do 78,000 watts divided by 450 watts, because that's the size of our panel. And the result is 173 1/3. So ideally, that's the number, 173 1/3 panels. So how many panels per string? So if we use the string sizing tool, this is the answer we get. The minimum number of panels per string is 6, the maximum is 21, and the optimum is 20 plus or minus 1. 20 plus or minus. So you have to just play with this number a bit. And so obviously you start in the optimum range. You start with 20 panels. And remember, we want to use 173. So that doesn't divide evenly, 173 divided by 20. But what you can get is 19 panels per string, 9 strings, you get 171 panels. So that's very close. So we're going to use that. And it's nice and uniform. 19 panels per string. And you see it's in the optimum range because 20 plus or minus 1, 19 is included. So this is what we're going to use. 19 panels per string, 9 strings, and we get 171 panels. So here, the inverter shown there is the bottom of the 60 KTL inverter. So there are 6 MPPTs. Each MPPT can accept 2 strings. So there are 12 string inputs, but we are only going to use 9 strings. So that is okay to have empty string inputs. You don't need to use all of the strings. If you have empty strings, it's okay. So next example, we have a 195 kilowatt requirement, AC. So step 1 is the AC to DC, the DC to AC ratio. DC to AC ratio should be 1.3. So you take the AC and you multiply by 1.3. 195 kilowatts AC times 1.3 equals 253.5. So that's our target for the DC. Number 2, check the space requirement. Okay, we've checked and there's enough space. Number 3, select the inverter. So in this, we would probably recommend 2 pieces of the 100 KTL inverter. So 2 inverters, 100 KTL each, 100 kilowatts each. So you actually are getting 200 kilowatts AC capacity. So step 4 is you check the panel and you confirm the compatibility. So you check the data sheets, you check the max current per MPPT, the max power current of the panel, and you check the compatibility. And we've done that and it works. It looks good. So step 5 is you calculate the number of panels you need. So if you take 260 watts, 260 kilowatts, you divide by the size of the panel, you get approximately 485.9 panels. So that's what we're looking at, around 485 panels. Now, how many panels per string? Okay, so if you use the string sizing tool, you get these results. At the top, the minimum number of panels is 6. The maximum number of panels is 21. And the optimum range is 17 panels plus or minus 1. So remember, we want 485.9 panels. So you play with these numbers. You see what number can divide evenly to make it standard would be good. So what we get is 18 panels. 18 times 27 is 486. So that's perfect. So that's what we're going to use. 18 panels per string, and we have 27 strings. 18 times 27 is 486 panels. That matches what we targeted. So here on the right side, you can see the inverters. This is the bottom of the 100 KTL inverter. Each inverter has 10 MPPTs. Each MPPT can accept 2 strings. So that means each inverter can accept 20 strings. Because each inverter has 10 MPPTs, each MPPT accepts 2 strings. 10 times 2, 20. So each inverter accepts 20 strings. Now, we're only using 27 in total, and we have 40 available because 20 on each inverter. So we have 27 strings, but we have 40 inputs available. So again, many string inputs will be empty, and that's okay. If we follow the steps, we've done our calculations, this will be fine. But look at what we have. So in example 1, we have, we're using 9 strings out of 12. And in example 2, we're using 27 strings out of 40. So now we're going to talk about MPPT arrangement, because the way now we have the number of panels in the string, right? We know how many strings, we know how many panels, but that's not all we can do to optimize. We can go a step further, and this is called MPPT arrangement. So we have another webinar where we talk in detail about what an MPPT is and what its function is. So basically, if you check the user manual of your inverter, it will tell you which inputs to use if you have less than all of them operating. So this image is from the 100 KTL user manual, and you see the table. So the table tells you if for each number of strings, which inputs you should use. And I can tell you the theory behind this. Number one is that these Huawei inverters have DC disconnect switches. So let me show you here. We're looking at the two inverters. Both of them, you can see the red circles. Those are DC disconnect switches. You can switch on and off the power to the DC. Each switch controls a block of MPPTs that it's next to. So on the left side, the 60 kilowatt inverter has 2 DC disconnect switches. They each control half of the MPPTs. And on the right side, the 100 KTL inverter has 3 DC disconnect switches. Each one controls the block of MPPTs that it is next to. So step one for optimizing is you should spread your strings evenly between the DC disconnect switches. Okay, so you spread them between the DC disconnect switches evenly. And the second part of the theory is you maximize the MPPTs. So you should not have any unused MPPTs. So part number one is you spread your strings evenly between the switches, and part number two is you maximize the MPPTs. But you can find this in the user manual. It will tell you exactly. So if you look where we have maybe we're only going to use 11 strings, it will tell you to use PV input 1, 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. So this is in the user manual. You don't have to memorize it. It's in the user manual for your inverters. Now the next part is the MPPT is still part of the MPPT arrangement. Okay, so when you have a complicated roof with different orientations and different angles and different elevations and different hours of sunlight. So like this image, you can see this house has a complicated roof with different orientations and different hours of sunlight. So you try to keep the different locations into a different MPPT. And each MPPT can accept 2 strings. So you keep those strings in the same location in the same MPPT. So you can see the image, it's clearly labeled that there's MPPT 1 and it has string 1 and string 2. And then at the bottom, MPPT 2 is taking string 3 and string 4. MPPT 3 is on, each MPPT is on a different location, a different angle, and the strings that are within a single MPPT are similar. So the 2 strings within one MPPT should be similar as possible. And if you have different angles, different hours of sunlight, those should be different MPPTs. That is how you will optimize. Okay, and next, so this is, you want to try to arrange your strings in a sort of a logical sequence. Um, if you can do landscape is better. Landscape is preferred over portrait. And this has to do with the way panels are manufactured. There's generally 3 diodes in the panel. And if your panel is landscape, you will get slightly better production. So I won't go into detail on this. It has to do with the way panels are manufactured. All we can say for now is landscape is preferred. You will get slightly better production because of the way shadows fall on the panels and the way panels are manufactured. But you want to try to keep your strings in a logical sequence, because all the panels in the same string will be limited by the weakest panel. So if you can, you try to have your strings separated, or at least row by row or something like that. You don't want to have your strings all mixed up, because the weakest panel will limit all of the panels. So landscape is preferred over portrait, and you try to make a logical arrangement for optimization. Okay, next we're just going to talk about running a simulation, because once you have done all of this, you may need to do a simulation for your customer. And Huawei is one of the best performing inverters on the market. So we've just showed you how you can achieve some of the best performance to reach the highest efficiency of your inverter. Well, the next step, I'm just showing you some images from PVSys. We will provide you the inverter files, the latest inverter files, so that you can load them into PVSys and you will get an accurate report. So PVSys is a simulation software, and on the screen here is showing you how to input the inverter files. So it's very easy, and you can find these instructions online. It's a very simple process. And we can provide you the latest inverter. It's called the OND files. OND for the inverter in PVSys. You're able to input the files. That's another one. You're inputting the files. And then you're able to put in all of the parameters, the location. You can even do a 3D shading design, and it will do a simulation of all the shadows. You will get results like this. It will show you your performance throughout the year, and you can even input your financial characteristics, and this will give your customer clear information about how much money they're saving and what is the return on their investment. Okay, so that is the end of the presentation. I know there was a lot of technical information today. I hope I explained it as clearly as possible. We will now go through your questions and see if there's anything that I can clear up for you. DC fuses and DC surge arresters are not required with Huawei. Huawei has built-in surge protection devices, type 1 and type 2. Personally, in my experience, I think DC fuses are a good idea, because if you have to do maintenance on the inverter, if you want to disconnect the DC from the inverter, you will have to wait until there is no sun shining, or you could damage the inverter. So I recommend to my customers to install fuses on the DC side, because in case you have to do some maintenance or if there's a problem, you can remove the fuses first, and then you can work on the inverter, because you should not remove the DC cables from the inverter while there is a current flowing. And you should not use the DC disconnect switches while there is a current flowing. So that means while the sun is shining. So I recommend that you put DC fuses, because it will make your life easier in case of any maintenance. But it is not required. Okay. How can we size DC breakers or DC isolators? Well, I mean, you just have to pay attention to the voltage and the current on your panels. So I think that's not really the topic we're here for today, but if you pay attention to the voltage and the current on your strings, you'll be able to size the DC breakers and the DC isolators. How do you determine the optimal panels to be used after determining minimum number of panels used in a string as well as maximum number of panels per string? Okay, so the string sizing tool shows you there. It shows you the answer. It shows you the optimum number. When you're calculating the minimum and the maximum and the optimum, the difference really is in the voltage of the voltage ratings of the inverter. So there's, as I showed you on the data sheet, there's the MPPT operating voltage range. It will give you like 200 to 1000. So the 200, basically, you input that number in the formula to get the minimum. You would use the 1000 volts in the formula to get the maximum. But there's also the rated voltage of the inverter, or sometimes called the nominal voltage. This is the optimum voltage. So if you calculate using that number, it will tell you what is the optimum number. And it's a range, so it's not like only you have to hit that number. You can go plus or minus one panel, basically. So sometimes the rated voltage will say 760 volts. And if you really look at the performance curve of the inverter, it's from like 650 to 830 volts. That's the optimum range. So they tell you the rated voltage, you try to get as close as possible for the best performance. And as I've said, the string sizing tool will tell you the optimum number of panels per string. Okay, do you offer services or training such as the energy monitor? Do you offer services or training such as the energy monitor? I don't understand the question, but the Huawei products, you get free remote monitoring, and we can train you on how to use that. So maybe that's maybe that answers your question. Can you please again share about DC to AC ratio? Okay, the DC to AC ratio. You want to oversize your DC. You should have more DC capacity than your AC capacity. The AC capacity is your inverter. Whatever rating of your inverter, or if there's multiple inverters, you add them together. That's your AC capacity. The DC capacity is your panels. You add up all of the panels. You want to oversize the DC by about 1.3. 1.3 is a good number. So you take your inverter capacity, multiply it by 1.3, and that's a good target for your DC capacity. The reason for this is because these capacities, we're talking about peak. So the panels, if you say, it says 450 watts, of course that only means in peak sunlight, from like maybe 12 noon to 2 p.m. every day, something like that. So it doesn't last a long time. So that's why it's okay, it's advisable to oversize your DC, because you will not reach that peak maximum very often. You will only reach it during the peak hours of sunlight every day during the year. So maybe only the summertime and not in the wintertime. So that means only during the peak hours will it be limited. It will be slightly limited. All of the other hours where it's not peak, you will be getting extra production, because in the morning you will be getting extra production from your extra panels. In the evening, you'll be getting extra production from your extra panels. So 1.3 is approximately the range where you get a good return on your money and you get better performance. If you go above 1.4, 1.5, you will have more clipping and you get a less return on your investment. So I hope that makes sense. If you need more information, you can message us. Could it be the conversion efficiency? Maybe you're referring to the DC to AC ratio. Yes, that is another reason for the high DC to AC ratio. Huawei inverters can have maybe 98% conversion efficiency. So there's 2% that you're going to lose. Other inverter manufacturers maybe have 97 or 96% conversion efficiency. So yes, this is a good point. This is another reason for the higher DC to AC ratio. For establishing accurate energy consumption. Okay. Can you please share some link that help to understand? I'm not sure how I can help you on that. You're going to receive this slides. You're going to receive this string sizer sheet, and this video will be on YouTube if you want to watch it again. I think you would have to just Google the topics that are difficult for you, or you can message us and we'll try to help. Will we can partner with JB Solar, or we have to work under the company JB Solar at EPC level? I'm not sure I understand the question. We generally don't do EPC work ourselves. The EPCs are our customers. So we like to supply and support the EPCs. So I'm not sure I understand your question. Will this presentation be sent to us? Yes, it will. Please, could the OND files work on Sunny Web as well? I don't know the answer. I don't know. You'd have to look into Sunny Web if they accept the same OND files. I don't know the answer. How can we reduce the shading effect maximum? I'm not sure I understand the question. It has to do with your panel's location. If you use PVsyst, you can design the accurate layout. So if there's trees, you can put the tree, you can put the buildings, you can put the cell phone towers, and it will simulate where the shadows will be for 365 days a year. So I think that's maybe the answer. You try to avoid the shadows. We have something called PV optimizers that we didn't talk about today. It's in a different webinar, but that also helps to reduce the shading effect. Please enlighten me on how landscape orientation is the best for mounting panels. Okay, it's too complicated for me to explain entirely, but it has to do with the way the panels are designed. They generally have 3 diodes. So the panel basically is divided into thirds behind the scene. You can't see it, but it's divided into thirds, 3 diodes. If the diode is covered, all of that third does not produce power. So if the diodes are basically the vertical lines. So the way that shadows fall on the panels, if you have a landscape panel, the shadow will come and cover 1 diode, 2 diode, and your third diode is still producing. But if you have vertical, a shadow will come here, all 3 diodes are covered, and this whole panel is not producing. That's basically it. I think if you want more information, you should speak to panel manufacturers, maybe Jinko, Trina, Longi. They can explain it in more detail. Can we get a webinar on the storage sizing? That is a good question, and I think we will do one of those very soon. We are adding storage to our catalog, to our products. So I think that this is a very good question, and I think we will do that within this year for sure. So thank you, Hamza. What happens if the MPPT is mismatched? I don't know what you mean. What happens if the MPPT is mismatched? I don't understand. If you want to type in a clarification, I can try to answer that. About data collection on the client's premises, what energy monitor service recommended, or one can reach for advice in case of huge project? Okay, so the Huawei products They come with free remote monitoring. So as long as you have the devices I mentioned, the inverter, communication device, the power meter, you will be able to see all of this from your phone, also from your desktop, from anywhere in the world. So yeah, I think that's the basic answer. If you have special requirements, we can assist you. But the monitoring is all included. You get to see it remotely. How to calculate excess models to be installed in order to charge the storage as well. Yes, so this is very complicated. I can't answer this today. We'll have to do another webinar for storage sizing. So yeah, that's completely different. So we'll have to do that on another webinar. Difference between array and string. Okay, I think generally an array is all of them, and a string is a string. A string is the panels that are connected in a series. That's one string. An array can be many strings. So I hope that answered your question. Is it required DC/DB for Huawei inverter? No, it's not. It's not required. For a 100 kilowatt AC Huawei inverter, there are 10 MPPTs. Each one has a capacity of 10 kilowatts AC. My question is, can I change that? Can I have different MPPTs with different kilowatt AC ratings? Okay, you're mistaken. The MPPTs do not have a capacity of 10 kilowatts AC. That's not how it works. The 100 kilowatt AC inverter does have 10 MPPTs, but there is no kilowatt capacity rating on each MPPT. The limit is the current. There's a limit on the current per MPPT, not the kilowatts per MPPT. So you can have different MPPTs with different kilowatt rating. You can. That's totally fine. But the MPPTs are not limited by the kilowatt. They're limited by the voltage and the current. There's the max volt, there's the operating voltage range and the max current. Is there any general formula of identified space required to install solar system? You can Google it. It will tell you the square meter per watt, but you also have to visit the site because not, the panels have a certain size. So you can't just maximize the space. You have to fit the panels in a certain way. And you have to avoid walkways and air conditioners and vents and windows. So there's not really a general formula. I mean, you can find just the square meter per kilowatt, but you have to visit the site. But if you input this, if you're able to do the measurements of the roof and you input that into a program like PVSys, it will do the layout for you. So you have to measure the windows, put them in the right location in the program, and it will do it for you. So I hope that helps. Difference between array and string. I think I've answered this. Generally, an array is many strings, and a string is the panels connected in one series. Main reasons of arcing. Okay, arcing. We didn't talk about arcing today. The main reasons are faulty connection or a damaged wire, but we talk about that in another webinar because we have arc fault protection. So there's another webinar for this. Thanks for the presentation. Thank you too. Thanks for the training. Thank you. You're welcome. Does Huawei string inverter have DC optimizers? It's a separate product. We have PV optimizers. It's not built into the inverter. It's something it's a product you can buy and install, and we talk about them in another webinar. Yes, correct. This is the product, Sun 2004 50 watt P, exactly. Will there be trading for off-grid / hybrid system with battery generator sources? So yes, there is. We have a PV diesel hybrid webinar of how to connect your PV, your solar, with your diesel generator. Currently, we don't have a strong offering on the battery side as a product. We don't sell a battery yet, but we're adding that very soon. And so I'm sure when we add that product, we will add the battery to the training. Currently, we have a training for the PV diesel hybrid. Can we open a company in Pakistan as a partner? We have an office in Pakistan, so you should reach them for more information. Do you have any presentation on inter-row spacing? No, I don't. Maybe we should add that to this one in the future. Rooftop, it's generally not an issue. This is mostly an issue when there's trackers. But I guess ground mount in general would use that. So no, sorry, we currently do not. Yeah. How to calculate height of PV panels from the ground? Okay, this is an interesting question. It refers to ground mount systems. So maybe we should incorporate this in the future. But no, there is no formula for that. You should basically just run a simulation, because when you go through PVSys, you can run the simulation, you can see how the performance is affected, but you have to think about the cost of the mounting structures and so on.